Okay, so the main focus of this module is actually going to be three-phase power. We're actually going to talk about something a little bit before three-phase power, but in this video here, I'd like to just kind of create an introduction to three-phase power. There should also be another video posted kind of talking about how a brief explanation on how three-phase power is even generated and why we're even interested in three-phase power. Now, when you look at three-phase power, you're going to see these kinds of graphs fairly frequently. And let me show you what I mean here. So let's see if I can sketch one that's pretty decent here. So I'm not going to bother putting my axes in here for this. Let's see here. Just trying to be careful when sketching these here so that we can get a relatively accurate looking graph here. That's not right there. Your eyes can kind of start bugging out when you're trying to draw these things here with all of these different ones here. So let's see here. Did I do that right? Yeah. There we go. All right. So you'll see these kinds of graphs fairly frequently. You won't see me sketching these too often, but you'll see these in texts. And if you ever work in the power area, you'll see these kinds of graphs quite a bit. And the idea here with three-phase power is you want to think of it is that this has got a phase angle of 0 degrees. And this one has a phase angle of 120 degrees. And this has a phase angle of 240 degrees. And this is actually three-phase power. Now these are all basically, you can think of being the same voltage at the peak, like 120 or something like that at the peak, but they're three phases. Now this is not what typically comes into a home. This does not come into residential homes typically. But this is often present in commercial. And it is, I would say, almost always present in industrial. So it's almost always present in an industrial application when you're doing any kind of high power stuff, or you have like any kind of motors or things of that nature. You often have three-phase power coming in. We have three-phase power coming into the labs at Indiana Tech primarily so we can conduct labs examining three-phase power. And if you come to one of the immersion weekends, that's one of the topics we will be covering in one of the immersion weekends is looking at, we have a really good motor system where we can look at both AC and DC motors, three-phase motors, look at how loads affect the power factors and torque. We have all sorts of really cool things that you can examine with this. Plus, you'll also be taking a course talking in more detail about three-phase system and three-phase powers. Your machines course will talk about that. This is really just an introduction. Okay, so one question we might ask ourselves, or at least to me it seems like an obvious question to ask, is why three phases? I mean, now there is another, like, why not 4 phases or 5 phases. There's some explanation on that, but I don't want to necessarily go into like specifically why the number 3. I want to talk about some of the advantages here of 3 phase over single phase. So let's at first examine that. Well, one of the reasons here is it provides greater power density. And when I say greater power density, I'm talking about the compared to single phase. And if it provides greater power density, what that means is we can use smaller wires. We don't have to use as large a wire, so it actually can reduce costs because wire can actually be a very large cost of things. Because I mean, if you're talking about, you know, having to have very thick wires or copper wires, I mean, you know, you can actually have pretty big deal. It also makes balancing loads is easier. It's more efficient for power transmission. And this is kind of tied into the first point here. It provides greater power density, use smaller wires. It's more efficient for power transmission. You know, if we can get greater power density with 3-phase, you know, and we're trying to transmit power across the country, you know, well, that would be more efficient for transmitting power. Because you might say, well, wait, you have to have you might have to have 3 wires then to transmit the power, but you know, you have to think about, okay, well, I might have 3 wires that are a smaller size versus 1 wire that's much larger in order to handle the same amount of power if you were to do single phase transmission. And those size of wires, because you're talking about, you know, you want to think about when you increase the radius, the cross section of those wires is a circle. So if you increase the radius, you know, you're actually increasing it by the radius squared, because area of a circle is pi r squared. So when you actually increase the size of the resistor, the size of the diameter of the wire you need, you're actually significantly increasing the amount of metal that you need for that wire. So even though you might be using 3 wires transmitting 3-phase power, you're actually going to still save money in the end because the wires are going to be smaller. You know, even though you'll have 3 of them versus 1. So there's plenty of other reasons. This also optimizes power efficiency or power factor. And you'll learn more about some of those things in your machines course, or if you were to come onto campus for the immersion weekend. You'll learn more about that. But let's take a moment here and look at, you know, there's a video that's posted online on how this is generated. I'm just going to draw a simple diagram here. And this is basically kind of how all motors work here. And so basically, we look at it that we have 3 conductors here. I mean, this is the kind of the simplest way to look at it. You know, so 3 wires here that are conductors. I mean, this isn't actually what the generators look like on the inside, but it's the simplest way to kind of picture them to see what's going on. And what I want to point out here is that these angles here are 120 degrees, because that's actually important, because that's how we actually end up generating the 3 phases. So, all right. So then what they do is they also have then in here a magnet for instance, and a magnet we know has a north and a south pole. And so basically, when you spin this magnet inside here, these are conductors here. If you spin this magnet, you'll actually, with the magnetic fields, you actually generate current in these wires. But now, depending on the orientation of this magnet, determines whether each of these wires has its peak or its minimum value. And the video explains in a little bit more detail. That's how we get these different phase angles for these 3 power generators here. And then basically what you end up having is like, okay, well, how do you spin this? And that's basically what power plants do. And so power plants, depending on where you're at, power plants, you might be burning coal, for instance, and it's not the burning of the coal itself that spins it. The coal is used to, typically what it is these are steam generators, and the coal is used to heat up water to create steam, of course, and then the steam turns, this is used to turn basically the crank and spin this. And nuclear power is the same way. It's just it's using nuclear energy to heat the water, a nuclear reaction to heat that water, as opposed to like burning coal. Now, of course, there's other ways to generate power that are very different. Wind power, for instance, if you're talking about those wind turbines that you might see depending on where you live, those wind turbines are basically the wind turning this crank. So I mean, there's the generator sitting up in top here, so the wind is actually what's turning this magnet here. Now, solar generation, there's 2 types of solar generation. One is still actually spinning a magnet like this, and that's where, if you've seen videos where they have mirrors in like a desert, and they're kind of angled to a center tower. Well, that center tower actually usually has, I think, like sodium, like pure sodium in it, and that heats it up enough to create liquid, and then that basically, all that heat is then again used to create steam to turn the crank. Now, of course, solar cells themselves are very different. They do not generate power this way. Solar cells actually generate, I'll just write it off to the side here. Solar cells generate DC power. And so if you've ever explored like putting solar panels on your home or anything like that and tie them into your power grid, one of the components you always have to buy is an inverter to do that. And that's because basically this inverter is simply a DC to AC converter. So you're taking your DC voltage and converting it into AC so that you can feed it back into the power grid, your power grid for your home. All right, but again, we're going to primarily focus on 3-phase in this module. So one last thing here I want to show you before we end this video is I want to bring up a little picture here. And so this is just not the only configuration for these towers, but you probably all have seen driving on the interstate or driving on highways, these big towers, and there's lots of different ways to build these. It's not like that this is kind of the only way to build it, but it was a nice, easy diagram that I thought so you could see one way to do here. And so basically you can see here there's 3 things on each side, and these are representing, basically this is what would be considered like a 2-conductor system, because we have one 3-phase conductor system over here, one 3-phase conductor system on the right hand side here. And so phase A, B, and C, this could be 0 degrees, 120, 240, and then there's a reason why you flip the phases here. I'm not going to go into that. And then these sky wires here, again, this is going into more detail on it that you would cover in a different course. These sky wires are really actually grounding wires and are just necessary for safety and for being able to transmit the power. Now, what you might see though sometimes, and some people get confused when they see this, is that you might see, for instance, where am I going here? I want to go back. No, where am I going? Here. You might see when you're looking at one of those things, you might see, for instance, a group of wires that are kind of connected like this, and then like there's a wire here, and then a wire here, and then a wire here. So, and you got 3. This is not three-phase wire, three-phase here. This is typically three conductors that are all conducting the same phase, and these three wires would be connected to, for instance, phase A. The ones I've seen more recently in the towers that have been built in my area are diamond-shaped ones that have four conductors on it. So there's four wires coming off of these here, kind of in a diamond shape here. And again, those four wires would all be in the same phase, and they'd be like connected here to phase A. So sometimes people get confused and they think when they see three wires together like this, they think, oh, those are the three phases. No, those aren't the three phases. The three phases are kind of these separate here. So if we go here, for instance, and look at a picture, that's still a sketch here. Here's a good one here. Let's just open this picture here. You can kind of see it. Open a new tab. So you can see it here for one phase, two phase, three phase. So you've got the three phases here. And it's hard to see. Doesn't look like they have the skyline wire attached on these. I'm not sure why they wouldn't have those, but you can clearly see this is exactly the tower we are talking about. So phase A, B, and C, for instance, and then phase C, B, and A. Now these are single wire ones still. There's only one wire, but this is where I'm saying you could have a bundle of like three wires attached here, or a bundle of four wires, and those would all still be in the same phase. It's just a way to be able to transmit more power, because, well, you've got four wires, so you're transmitting, the same phase, but you can transmit more power that way. And again, instead of making one bigger wire, having the four smaller wires often ends up being cheaper than making one big wire. Okay, so we'll end the video here and pick up with some other things next time.